Okay, we're going to go ahead and get started. This is Michael McClellan. I'm with L3 Levine Electronics and Electrics. Thank you so much for all of you who have attended our recent webinars. It's so good to have participation and folks asking questions and having a productive discussion. You guys seem to ask very good questions. Today we have a special treat. We have two panelists with us. We have Dave Whitman. Dave is with UST Corporation up in New York, upstate New York, and is going to talk about power quality. And our own Adam Norell, one of the partners here at L3, is going to share some of his experiences with voltage sag issues and the UST product. So it ought to be very informative for all of us. Before we get started, just a quick housekeeping issue. This is a webcast format, so your phones are muted. But we'd love for you to ask questions and participate in the discussion. There is a button, I believe it's on your right-hand side, it may be on the left, that's a magnifying glass or maybe a question mark, and that allows you to bring up a dialog box and to ask your question. And depending on the question, we may answer it immediately or go on to answer it at the end of the presentation. I have attached a few handouts to this presentation. You'll see those in the same toolbar with the question box. They are things like white papers and brochures and that kind of thing for your later enjoyment. And so without further ado, let me turn it over to Dave Whitman and Adam Norell.
Thank you, Michael. Appreciate the opportunity to present today. And we're going to give you a quick snapshot of Utility Systems Technologies, UST for short, and just give you a sense of the company and the products that we manufacture in the power quality arena. We're located in upstate New York. We do all of our manufacturing here in the United States. We source components all from US vendors, and we're a company of about 20 to 25 people. We ship to countries all over the world. We are a global company, if you will. We do a lot of business with the United States government and the State Department, which allows us to ship product to some very unique countries. But we get inquiries from all over the world. And in fact, as you might imagine, some of the power quality issues are more prominent in some of these developing countries. So we have some activity there. And we also obviously do a fair amount of business here in the US. We have two core products. The first product I'll mention is the Sag Fighter. It's a sag mitigation device. And these are just a snapshot of some of the companies that we've done business with over the years with this particular product. The other product we manufacture is a voltage regulation product called the Surevolt. That's an electronic tap switching transformer with a control board. And again, here's just a snapshot of some of the companies we've done business with over the years. All kinds of industries, from medical to semiconductor, government, aerospace, universities and labs, that sort of thing. Anybody who's looking for, has a process or a piece of equipment that requires good clean power is always an application for our type of products. As you all probably know, we experience all kinds of power related issues. Some are caused by degrading grid. You might be purchasing new equipment that might be more sensitive than perhaps some older type equipment. So it's not as resilient to some of the electrical events that are occurring in this day and age. And there's also weather related events that might be occurring that may cause sags within your factory or in your plant that we all look for to try and alleviate, so we can protect your equipment as best we can. This would be a good opportunity, Michael, for the first poll question. Just thought I'd mention that. So we look at power quality as three types of events. The first event or first consideration is a chronic voltage problem where you have an ongoing high or low voltage situation. The next segment would be voltage sags. These typically are quick, sometimes only 2 or 3 cycles events, but they are long enough duration to cause issues with your piece of equipment, your process, your factory, whatever it may be. So the top 2 are issues that UST has products to address. The third event type is a complete interruption. We leave that for the UPS people. We do not have a solution for issues with complete interruptions. We have a very simple design. We use a minimal number of parts. All of our components are typically off-the-shelf type components, so they're easy to replace if needed. Our base design has no moving parts, so it's highly reliable. We use natural convection for cooling in our NEMA 1 enclosures. We can maintain the load during any type of failure with a bypass arrangement. Very simple product to install. We designed it so we wouldn't have to go out and install this product. It installs like a simple transformer. So basically, we ship the product from our factory, and we don't have a need to go out and commission the units unless there are certain circumstances which may dictate that. To separate the 2 products, we have a graph that indicates on the vertical axis you have sorry about that. Let me back up. On the vertical axis you have voltage, and on the horizontal axis you have time. So the green box indicates a good application for the Surevolt product, which is our voltage regulator, and you can see it will correct for voltage between 75 and 110% of nominal, and it'll do this correction continuously. The Sag Fighter is a little different product. It can correct for deeper voltage sags, and it does it much faster, and it maintains the correction for 100 seconds. So we look at when someone supplies us with data, oftentimes we'll go to this chart and plot out the points and see where the points fall, and this helps steer us into the proper direction to apply the appropriate product to the application. So it's just a good little useful tool that we use. So first we'll talk quickly about the Surevolt. Again, electronic voltage regulator product. We build it from small to large, single or 3-phase applications. Currently the largest unit we've built is 3500 kVA, 50 or 60 hertz, no problem. And generally we play in the 600 volt or less arena. Another nice feature is that we can step up or step down the voltage. So for instance, if you had say you bought a machine from Europe and it ran on 400 volts, but your factory is 480. Well, we can supply a product that will make that step from 480 to 400, and will give you 400 regulated voltage to plus or minus 3%. So it eliminates the potential need for an independent step-down transformer. And we also have optional voltage ranges. We are a build-to-order shop. We do a lot of customization with both the unit configuration and the enclosures. So any enclosure type of requirement, we can certainly take a look at. Again, as I mentioned, we build from small to large. Here's a typical example. You can see the simplicity of the design. We have a control board, some SCRs. All units come with an input circuit breaker. We have a set of MOVs for surge suppression. And we also have an automatic fail-safe bypass. We provide a set of output lugs for your to supply your load. And as you can see, very simple, easy to maintain device. If I flip that product around, the rear of the device simply has the magnetics. The unit also comes with a 3-button status display. What we're illustrating there is you'll be able to identify which phase and which boost number we are on when we're regulating voltage. Also has date and time and 3-button navigation. It also has some logging features commonly used for troubleshooting if needed. We're going to log all the tap changes that the unit makes, and it also will display error messages as needed. This particular product has a very high and robust inrush capacity. Most of the other electronic voltage regulators in our segment have a overload protection of 1000% for 1 cycle. The UST product is 1000% for 1 second, 60 cycles. So a tremendous amount of protection built into the unit to protect it from any potential failures. The way we do that is on the right-hand side of the screen is the UST design, and on the left-hand side of the screen is a typical electronic tap changing design by other manufacturers. And you can see we employ a series transformer to protect our SCRs against any faults across the output. Whereas on the left-hand side of the screen, if you have a fault across the output, the SCRs are in direct line with potential failure. Therefore, we do this to give our unit a little more robust capability. And because our SCRs are protected, the weak link in our design is really the magnetics, and the chances of the magnetics failing is quite minimal. This just is a representation of the way the unit operates, and you can see with the red line, as the incoming voltage changes, we are changing taps with the green line in order to maintain a plus or minus 3% output. Same representation, only this is an actual test sheet. You can see the upper chart is us varying the voltage with our variac and increasing the voltage and then decreasing the voltage. And on the bottom chart, we're watching to make sure the taps are changing to ensure plus or minus 3% output. So benefits of the Surevolt: we have a very high overload capacity. There's no interruption of switching. SCRs are never overloaded. We have no moving parts. We're compatible with all load types. And again, we have an automatic fail-safe bypass. The bypass is there in case there is some kind of unit failure. We're able to trip to bypass immediately and maintain the load. Other products in this category may, when they have some sort of internal failure, they may take the load down with them. We don't do that. We have a bypass arrangement that will maintain the load, albeit with unregulated voltage. We provide a complete set of drawings with every unit, both mechanical and electrical. So if the product is purchased, you'll be presented with an approval drawing that must be reviewed and signed. A full set of schematics. And then when we ship the product, we provide installation and handling drawings to provide all the information needed to install the product correctly. So again, key feature of the device: no moving parts, very easy product to maintain. Basically, the maintenance schedule is an annual inspection and cleaning. That's the most important aspect of maintenance. And this would be a good time for the second poll question, Michael. So now we're going to talk about the Sag Fighter, which is a sag mitigation device. And again, as we talked about earlier, there are interruptions and there are sags. Our approach with this product is that a facility will experience far more sags on a per year basis than interruptions. Generally here in the US, power grid is pretty good. not too many interruptions occur. But there are sags. Sags occur because of weather-related events, or oftentimes utility changes and switching on the grid that may cause a quick sag. So the Sag Fighter is a product that offers protection against that type of event, where you don't go all the way to 0 volts, but you may experience a sag of significance. This was a study done by EPRI that just reinforces what I just mentioned, that there are far more sag events occurring in our environment than there are complete interruptions. So what does a Sag Fighter do? It fills in sags by adding a correction voltage. We make a correction, we recognize a voltage sag. What the device does is it sets a threshold at about 90% of nominal. So anytime the voltage is above 90%, we're simply passing the voltage on through to the load. We're sitting there in standby. When an event occurs, and we set that threshold at 90%. So if the voltage drops below 90%, our control recognizes that and will inject the appropriate voltage on the appropriate phase, and it'll maintain that correction, and the correction accuracy is within plus or minus 5% of nominal. It makes that full correction within 2 milliseconds. So it's obviously a very fast responding device, and it can correct a single phase sag down to 10% remaining voltage, or a full 3-phase sag down to 60% remaining voltage. So it corrects for deeper sags in voltage than the Surevolt voltage regulator. So 2 different applications, really. Additional features, it's very efficient, operates at 99% because it's primarily sitting in bypass a majority of the time. We can power industrial loads. We're very, with our high inrush capabilities, it's an excellent application for industrial type environments. Very little maintenance, again, very few moving parts, and there's no hazardous materials or batteries on board or involved with the installation. This is just a simple representation, scope shot, if you will, of a sag event occurring with the blue sine wave, and then the pink sine wave showing the correction and how it immediately gets back to a full sine wave and a complete correction. Same type of scope shot, only here we have a 3-phase event. So you can see that on the input on the left-hand side of your screen, and then how quickly the Sag Fighter will make the correction and give you nice clean output. So Sag Fighter features protection against deep voltage sags. It'll balance the phases, make the appropriate correction on the appropriate phase, correct for any phase shifting or waveform distortion. Again, there's no energy storage. We don't use capacitors. We use a inverter transformer type design. And again, we've made the product so it's very easy to install. So this is a representation of the Sag Fighter in standby mode, where it's simply passing good clean voltage on through to the load. We're watching the input with our control, and we have a series transformer that is shorted in the design with SCRs. And then here's our inverter. Now, when a sag event occurs, we recognize that with our control. We unshort the transformer, and with the inverter, we inject the appropriate voltage onto the appropriate phase, and we make that correction within 2 milliseconds, and we're able to maintain that correction for as much as 100 seconds. This is a graphic representation of the Sag Fighter specification. So this is a 3-phase sag. It's actually, I find the easiest way to read this is from right to left. So we've got incoming voltage coming in, and when that voltage hits the 90% threshold that I mentioned, the Sag Fighter comes on, and it tries to get the voltage back to nominal within plus or minus 5%, which is represented by the green. And down below here is the voltage sag. And as the sag increases in voltage, the Sag Fighter continues to correct all the way down to 60% is our specification. 60% of nominal voltage, we're still maintaining 5%. And then if the voltage goes down below that, you can see it start to fade off. Now with a single phase sag, same thing, we're coming down with our nominal voltage. We hit 90% threshold, we boost it back up, and we're outputting nominal voltage plus or minus 5%. And as we get down to almost 10% of nominal voltage, we're still able to maintain a plus or minus 5% condition on the output. So Sag Fighter features or specifications, if you will. As I mentioned, down to 10% remaining voltage on one phase, 60% remaining voltage on 3 phases. What the product is doing is, because we don't have any energy storage, we're taking advantage of the energy left on the system to boost the phases that may need correction. So we're taking advantage of what's there. So we don't need any batteries or capacitors to inject more energy into the system. We're simply taking advantage of what's there and remaining. All the corrections are back to 95% of nominal, plus or minus 5%. Again, as I mentioned before, 2% response time. It is a SEMI F47 compliant device. That's important for people in the semiconductor industry. And will correct for phase shifting and independent of load or power factor. Okay, sizes. We build this is a 3-phase only device. We've built up to 2000 kVA. We can build 50 or 60 hertz. And again, we're working with 600 volts or less. And because we're passing the voltage on through in standby mode, we do not have the opportunity to step up or step down the voltage. This is just a quick photograph of a typical Sag Fighter with the doors open and some of the major components. This particular photograph shows a 3 circuit breaker bypass, which is an option on the unit, so we can completely bypass the unit if necessary for servicing. Just a snapshot of one of our bigger units, a 2000 kVA transformer. There's a snapshot of a unit that's approximately 1000 kVA. The unit does come with a touch screen to interface with the unit. On the touch screen, you can capture historical data, any error messages, and it'll give you the status of the unit. So if you engage with the touch screen and look up your SAG history, the unit will give you a starting point and ending point, if you will, of any given SAG. And if you click on the SAG, it'll give you specific information about that SAG. So what the voltage was doing across all 3 phases and how long that SAG event occurred, what the duration was. This is all accessed through the touch screen. And so at any point in time, if you had an event the preceding evening and you want to see if you had any SAG events, you can go up to the Sag Fighter, hit the touch screen, look at the history, and identify any potential problems that occurred in the past 24 hours or back at any point in time. The unit also will display error messages as needed. And again, some of the benefits, very low owning costs. So when you compare us to a UPS, we don't have the ongoing servicing of the equipment. So our Sag Fighter is a one-time purchase with very little maintenance involved moving forward. It's very efficient and it's very easy to install. So we don't have any ongoing costs that we need to be worried about. It's always online. There's no reset or recharge. Some of the other products in this arena may need time to recharge capacitors. We don't have those issues. And it's most ideally applied in a critical manufacturing process or a piece of critical equipment. That's the most common application for this type of equipment. And quite honestly, I'll mention that we do sell probably almost more Sag Fighters than Surevolts in the US, again, because the US grid is pretty good, but everybody's experiencing sags, so oftentimes the Sag Fighter is the more appropriate product. Installation, I mentioned this, very easy to install. Installs pretty much like a dry type transformer. We do provide an input circuit breaker on the device, so your input connections all go to the input circuit breaker, and then we provide a set of output lugs for your load. Again, I mentioned maintenance, very simple. And again, here's this chart that we use to separate the two products, just to circle back. Voltage regulator is going to continuously monitor and make tap changes to make corrections for voltage. The Sag Fighter is going to sit in standby, waiting for a sag to occur. Sag Fighter can correct for deeper voltage events. And I'll just mention, we do have a website if you want to go there and investigate our products. It's fairly thorough, a lot of good information there. One neat little tool that we do have on the website is a return on investment tool for the Sag Fighter. So if you're an end user, or if you have a client that understands what their lost production costs is, you can move this bar up and down and say, okay, whenever I have an event, it costs me $40,000, and then you can type in or move to a particular KVA requirement and estimate approximately how many sags per month you encounter, and the calculator will move and give you a sense of whether you have a good application and a good return on your investment. So just a fun little tool to use to kind of see if you're in the ballpark to consider our type of equipment. And that's it. I appreciate your time. I just wanted to mention and thank L3 for the opportunity. And obviously, if you have any questions down the road, to reach out to these guys. They represent us throughout the entire Southeast, and they do a great job for us. So I'll leave it at that. And I don't know if Michael or Adam, you have any further input.
So Dave, it was a great presentation, and you covered it in a record amount of time. But that's a good thing, because we've got several questions that came in from our audience.
Okay.
So let's take them one by one. Here's a good question. We are working on a project with an autoclave that requires a voltage between 220 volt and 235 volt for proper operation. The equipment data sheet says voltage outside of this area requires a buck boost transformer that's 0.5 kVA. Would your Surevolt product be something viable for this application? And have you been able to coordinate voltage requirements with equipment manufacturers?
Yes, typically equipment manufacturers are looking for a certain tolerance in voltage to ensure that their equipment is going to work properly. And that's what we provide. If the client is unsure of what his incoming voltage is, and he needs some sort of guarantee because he's got this great big expensive machine, we're going to provide nominal voltage plus or minus 3%, which is pretty tight and pretty acceptable to virtually all industrial equipment. If the client needs it tighter than that, we can go to plus or minus 2%. We do compromise a little bit on the input range that we operate, but still, if someone is looking for tight voltage regulation for a particular piece of equipment, that's a good application for our type of device. We see it with machine tool manufacturers, and I'll just mention that production machines, whether it's machine tools, whether it's conveyors, whether it's packaging equipment. They're getting very sophisticated, and because of that level of sophistication, they become sometimes a little fussy and a little sensitive to incoming voltage. So there again, it might be a good application for our product.
Fantastic, Dave. Okay, here's another one. Are capacitors used at all in the Sag Fighter?
They're used within the inverter, and that's it. We do not use capacitors for energy storage to inject back into the system.
The next question is, will this system work on a HRG system, a high resistance ground?
Boy, that's a question for an engineer. I don't have an answer to that.
All right, we will get back to you within 48 hours on that question.
I don't believe there would be any issue, but I'd rather run that one by an engineer.
Yeah, I would think so too. So it would be utilized the same way as a transformer, Michael. So I wouldn't see any issue with it as long as we've got it as a Y connected. So it should be fine.
Thanks, Adam. The next question is this product still for 600 volt and less?
Yes, both Surevolt and Sag Fighter 600 volts or less. We do not build product beyond that.
Great. The next question that came in is, what happens when a fault occurs on the output of the Sag Fighter?
Depends on the severity of the fault. The Sag Fighter will has an input breaker and will open its input breaker if it reaches a level where the Sag Fighter will protect itself. So it's going to evaluate the severity of the fault and make a decision as to what to do to protect itself.
Yeah, there's also, so typically we're going to sell it with an input breaker, a bypass breaker, and an output breaker. Between the output breaker and the connected load, if there was a fault on that cable, that output breaker is going to trip, so that it at least protects the Sag Fighter and anything upstream of the Sag Fighter. Typically something we're feeding is going to have a breaker on it also. Obviously we would hope it would trip, but at least we know we'd be able to trip the output breaker of the Sag Fighter.
Fantastic. Another question, this is a good one. Does this equipment have a SCCR? I'm assuming that's silicon controlled rectifier.
It's SCR, not SCCR, I would assume. That might be a typo, but yes, the Surevolt uses SCRs to create the tap switches, and the Sag Fighter has SCRs to short and unshort the transformer quickly.
Yeah, the SCRs is the way we're able to achieve the fast response as well, because basically, like Dave said, doing that tap changing is what's going to fluctuate that voltage on the output voltage to give the load what it needs. But it's all done SCR wise to be able to maintain the speed that we're offering on the product. Right. But the good thing is it's SCR, so it's solid state switching, so it's not like it's a mechanically moving product. So millions upon millions of operations on it.
And we can make a complete voltage correction in 2 to 3 cycles, whereas a mechanical device is going to take seconds, perhaps, to get to where it needs to be. So our position is it's better to have the speed, the high speed, in order to make that correction, because the load will then have a better chance of riding through any variation in voltage.
Great answer, Dave. The next question that came in is, what is the mean time between failures?
That's a gray area. We have a statement. I don't know it verbatim, but I'll just answer it by saying this, that we've been building this product since year 2000. So we're in the market for 20 years. We have product that's been out there for 20 years. And because of the nature of the design and the robust design, it does very well. We have very few failures. We have an extremely small field service department because we just simply don't have many failures in the field. So you can shape the statistics any way you want them with a lot of mean time before failure statistics. So if that particular person is interested in our blanket statement, I can certainly provide that to you. But I'd rather speak to the fact that the product's been in the market for 20 years and we've had a high amount of success and a very low failure rate with the product.
Yeah, Adam, you've sold quite a few of these yourself. Have you experienced many warranty issues?
Knock on wood, I have experienced 0 warranty issues. I've been selling the product since 2013, so 7 years.
And Adam has shipped product all over the world for us.
Fantastic, thank you for that. The next question that came in is the equipment listed by an OSHA approved NRTL? And so I'm going to assume that's a nationally recognized testing laboratory. And perhaps this person is referring to like a UL listing or CSA US?
Right, UL listing for some of the smaller sizes up to, I want to say it's 250 kVA. And it's for common voltages. And then anything beyond that is typically becomes, as you get into the bigger sizes, people want little nits and gnats to make it custom to their application. So that makes it very difficult to UL. So what we offer as an alternative to UL is 2 options. We have CSA, which is a international standard commonly used in Canada, but it is recognized internationally. And the other certification we offer is TUV, and that is another internationally recognized standard. So we offer those on the larger sizes, or perhaps a unique model that might be smaller and not under our UL listing or in our UL file. We do the CSA and the TUV on a case-by-case basis, and we simply just charge for that on a case-by-case basis. So if we're shipping a product to Canada and they insist on it being CSA inspected and labeled, we have a CSA inspector come to our facility before we ship, and we have him go through the product and label the product for us.
It's a great answer, Dave. The next question that came in is, for dry type transformers, our maintenance plan calls for every 6 years to perform the following: polarization index, AC power factor test, TTR test, etc. Would this be needed for the Sag Fighter as well?
To the best of my knowledge, we do not require that as part of any maintenance routine with our product.
Just to clarify though, so there is a dry type VPI design transformer in the product. So if it is a requirement at the end user site to do that on all of their and a lot of times I imagine that question's coming, they're probably doing that on their medium voltage step down transformers. I doubt very seriously they're doing it on their low voltage, say 480 volt or 600 volt or 208 volt transformers. If they are, then then yeah, they would want to apply that same to our dry type unit because it is a VPI type transformer inside of our product. But typically that's not done from a maintenance standpoint on low voltage product.
Thanks, Adam. The next question that came in is, on an HRG system, one of the concerns is MOVs. Are there MOVs in this device?
Yes, MOVs in both products. I need to defer to an engineer to understand what the concern might be.
Sounds great. The next question is, do you have experience with open delta applications, center tap or corner grounded, typically at 230 volt AC 3-phase for pumping applications around 10 horsepower? We'd like to see if the price point is justifiable to protect and keep our VFDs running during a sag.
I wonder if that means, Michael, I'm assuming they're referring to they've got a single phase drive on that pump application. That's what I assume when they mention center.
No, Adam, that's not the case. What some utilities do, instead of bringing 3-phase to the transformer, they only bring 2 of the 3 legs. So it literally is a delta. It's 2 single-phase transformers that they make into a 3-phase transformer. So yeah, the Sag Fighter would definitely be a solution for this application. It would help keep the voltages up.
Or the Surevolt. We've done some unique delta arrangements with the Surevolt. We've already been down that road, and we've already got drawings, and so I don't think that would scare us away. It's pretty small application, 10 horsepower, but we might consider it, sure.
Edson will get in touch with you after the webinar and get some more details. The next question that came in, what is the short circuit current rating for this device? And I'm assuming this is a withstand rating.
So typically the projects I've been involved in, especially on the larger kVA size, we've designed them at 65 kA, and the input, output, and bypass breakers have been at 65 kA as well. But it's an engineered product most of the time when you get above the 225 kVA. So if there's a higher requirement, such as 100 kA, then we can definitely look at that from a design perspective. But typically it's 65 kA.
Yeah, on the bigger stuff, we're build to order. So we build to a specification. If someone provides us with a specification with a specific KA requirement, we can source, and we can source those circuit breakers. We'll certainly do so.
That's great, Dave. Last question. Will either of these systems contribute to the overall harmonics back on the incoming line?
Good question. Simple answer. We introduce no harmonics and we remove no harmonics from the system.
Fantastic. Well, that's all of our questions.
I'll just, if I could just mention one more thing. The collection of data is becoming more and more important in this process of considering this type of equipment. So I cannot stress enough the value of a client collecting voltage data and presenting it to us. It just makes it a much easier process, and it allows the client to understand what his problem is and whether our product can fix it or not. So if there's metering opportunities out there to collect some data, it is extremely useful in the process.
Okay, that's an interesting segue into, we do have meters here at L3 for rent, and we can come out and put them onto your system. These are portable meters that sample at a rate of 1,024 samples per cycle. So they are certainly fast enough to capture any voltage sag or swell. Feel free to email us if you would like to a proposal on putting a temporary meter on your system for recording purposes. Looks like we've answered all the questions. Dave, as usual, fantastic job. Thank you for your comments, Adam. And thank you all for your participation and questions. We hope to see you on our next webinar.
Hey, Michael, one thing I was going to say just while the attendee is still on, just thinking of applications where we've been successful in the Southeast, hospitals that got sensitive equipment such as x-ray machines and stuff, that's where an application, if there's anybody that's doing designs or projects for hospitals, these fit well with that. Pump stations, lift stations that are out in the middle of nowhere that have a poor voltage source, this works good for sure. And then of course, in any kind of process where there's sensitive drives or PLCs, I get a lot of calls from industrials that have PLCs that are tripping off because they see a very slight voltage dip and they trip off. And of course that eliminates all processes at that point when they lose the PLC. So just kind of 3 examples that I see on a fairly regular basis.
Those are great comments, Adam. Thank you everyone for your attendance. And again, we hope to see you on our next webinar. Thank you. Have a wonderful day.
Thanks, Michael.